going to play with the normal distribution here, but we're going to talk about distribution in general with the mean and the standard deviation. So we have ourselves three cities. We have got the beautiful city of Indianapolis, the fun city of Austin, Texas, and then the California southern city of San Diego. So could the normal distribution curve shown on each of these histograms lead to good approximations of the curve? Why or why not? I would say yes. Reason, all of these appear to be approximately normal. And when we talk about a normal distribution, right, you think about the normal distribution curve, it's pretty close that if you put a slice down the middle, they're pretty similar on the left and right. I mean, they're not perfect. Obviously, nothing is perfectly symmetrical, but it's pretty close. So because they are approximately normal, we could say, yeah, they're a good approximation, right? These are estimates. Nothing is perfect, but they're decent estimates. Compare the graphs. How are they the same? How are they different? Well, if we look at the same, looking at the same of each one of these, we will notice that they all have the same mean. So if we look at where we're at here in terms of the graph, right? So the normal distribution in the middle of that is the mean. So they all have the same mean or the same average because that's right above 65 to 90. If we want to talk about how they are different, ooh, that's a bad color. If we want to talk about how they are different, look at the spread. So San Diego is super high, Indy is kind of spread out, Austin somewhere in the middle. So they're different by the spread of data, which we often talk about as the standard deviation. So the spread of data, how it's all like with Indy, you're going to have a bigger spread than with any of the other cities. So when we talk about the mean, we talk about the average, right? The average temperature. The standard deviation talks about the spread, how much the data deviates from the mean. So if the average is 68, but sometimes you have days that are 30 and some days you have days that are 110, that is a big range of temperatures. And that's where we get into higher standard deviations. Whereas if every day the temperature is somewhere between 62 and 72, that's not a very big range. So standard deviation talks about that idea. Now when we talk about the curves, a larger standard deviation will be kind of like flat and low, where a smaller standard deviation is kind of like tall and skinny because all of the data is clustered around the mean. Whereas when it's really spread out, right, the mean is in the middle and the data just goes in both directions, just swooshed out. So you can really tell by a curve whether or not you have a large or a small standard deviation. So back to this. Let's rank the cities in terms of temperature variability. Who has the most variation and who has the least? So we'll put most at the top. We'll put least at the bottom. When we talk about the most variability, well, that has to be Indianapolis because it's the most spread out, right? It's the shortest because it's all over the place. So the most variable is Indy. The least variable is going to be San Diego because it's the tallest and skinniest bar. So the least is San Diego, and then Austin is somewhere in the middle. Now, what does this mean for their standard deviation? Well, it simply means that Indianapolis is going to have the largest standard deviation, and San Diego is going to have the smallest. Austin will be somewhere in between Indianapolis and San Diego. So that's what it means. If you have a small standard deviation, a small range of terms of your graph, then you're going to have a small standard deviation. All right, let's move on to a different graphic here. We're looking at course grades comparing fall and spring. So spring is the solid line here, and then fall is the dotted line here. Okay, so why is that not working? Oh, because I made it dotted. So sorry. Okay. Number Number 4, which curve appears to have a lower standard deviation? Now remember, the lower standard deviation means the least amount of spread. And that's going to be this curve, the one that is like mushed together, and that is spring. So because spring is more of a smush, right, there's less spread, it's going to have a lower standard deviation. Number 5, which semester did students have more Fs? Well, an F is less than 60. So if here's 60 and we go less than 60, you can see the dotted line is up here pretty high. So that means fall because there's way more students above the solid line. And the last question, when were more Cs earned? Well, a C goes from 70 to 80. So we have this this part up here, which is, in the spring where it's more, and then there's a little bitty space here where fall is more. But which spot is bigger? The spot that I'm coloring right now, that's like a purplish, or this pinkish? Well, the pink one looks to be a bit bigger. So we're going to say spring. And frequency, right? So you have this has a higher frequency. So like 100 students had this, whereas it's only like maybe 40. So spring has more Cs, and that's because all of the grades, right, with the spring, they're all clustered around. So because the majority of the grades are clustered around that average of 70, that's also going to lead us to more Cs being in the spring, whereas the fall semester had more Fs.